All right, this video is going to have all of the answers to the test review to help you prepare for the upcoming test on functions. So pay attention to what you're doing and how it's being explained, especially if you didn't get the question right or if you didn't understand what to do. All right, so for numbers 1 through 4, you are going to plot, that's what that hole says right there, and label the order pairs in the coordinate plane. Because it says plot, you do not connect them. So you're literally just showing me that you know how to graph a dot on the order or on the coordinate plane. So for 4, 6, we're going to start at the origin, go right 4 and up 6. And put letter A. Make sure you're labeling as you go. For letter B, it's 0, 3. Start at the origin, go up 3. There's letter B. For letter C, go left 3 and up 5, which should be there. And for letter D, 4, 0, you go right 4 and then stop. So that's letter D. All right, so that's what 1 through 4 is asking you, is do you know how to graph a point? For 5 and 6, you are completing the table values and then graphing the line. Because it says graph the line, you do have to connect your dots and make a straight line with arrows going through it. All right, so the first thing we want to do is plug in our numbers. And because they gave us X, this is easy to do. You don't need to show work. Just plug it in your mind and do the math and then come out with a Y. So -1 plus 2 is 1, 0 plus 2 is 2, and 1 plus 2 is 3. So now I've got 3 ordered pairs that I'm going to graph on the coordinate plane. -1, 1, 0, positive 2, and positive 1, positive 3. All right, do not leave me with random dots. You are now making a line. So take your straight edge, connect it, and put arrows at the end of your line. Now, number 6 is a little different because they didn't give you the X values, they gave you the Y values. So anytime this happens, you have to put the Y values in and solve a two-step equation. Right? So it does take a little bit longer to do this, but it's still just as easy. It just takes 2 steps. So put in the 9 first. We have 9 equals 7 minus 1/2 X. Right? Now, to solve a two-step equation that looks like this, we would subtract 7. 9 minus 7 is going to give us 2 equals -1/2 X. To get rid of -1/2, we're going to multiply both sides by -2. And when we do that, that crosses off the fraction on the right-hand side. And that gives us X equals -4. So for this first one, -4 is your X value. Now, the nice thing about setting up the equation this way is once you've set up the first time, all you have to do is take and change the numbers. So that 9 is going to change, that 2 is going to change, and the answer is going to change. Everything else stays exactly the same, right? Your process didn't change, your numbers changed, right? So now we're going to plug in the 7, the positive 7. So if I put in 7, 7 minus 7 is 0, and 0 times -2 is 0. So my X value for that one is 0. Again, I'm just going to take the 3 numbers that I just put in there out, and I'm going to substitute the 5 in. So when I put the 5 in, 5 minus 7 is -2. -2 times -2 is +4. And that's how you get those X values when they give you the Y values. Now that you've got the table filled in, you're going to go over to the graph and make the picture happen, right? And when you plot your points, if it doesn't make a straight line, you know something didn't happen right either in your calculations or in your graphing, because it always makes a straight line at this point, right? So for -4, +9, that's left 4 and up 9. 0, 7 is right at the origin and up 7. And then 4, 5 is right 4 and up 5. Right? Take your straight edge, connect your dots, put your arrows at the end, and that's what that line would look like. Right? So be careful if I gave you the Y value and not the X value. All right, for 7, 8, 9, and 10, you have multiple choice here. I've given you 4 tables and 4 equations, and you're going to match which one goes with which. Right? Well, one of the fastest ways that we talked about was the starting value, if it's there, or the pattern. And if you look at your problems, all of them have a different pattern in front of the X. So that's going to be the fastest way to pick which one goes with which piece, right? And remember, for the pattern, it's always the change in Y over the change in X as a ratio, right? So I'm going to pick any 2 numbers on the graph, and I tend to pick the later 2 in the table just because they're positives and easier to do than the front 2 are, but you can pick any 2 and it'll work. So to go from 2 to 6, you add 4. To go from -5 to -1, you add 4. So my ratio is +4 over +4, and 4 divided by 4 is 1. So I need to find the equation that has a 1 in front of the X. And if you look over to the left-hand side, number 8 has the 1 right there in front of the X, and that means that number 8 is letter A. All right, for the letter B table, same process, right? So this time I'm going to use the 1 and the 2. To go from 1 to 2, you add 1. To go from 1 to -2, you're going to subtract 3. Okay, and then you're going to put your y value, which is -3, over your x pattern, which is +1. -3 divided by 1 is -3. So now you come over to the left and find the equation that has the -3 in front of the x, which is number 10. So number 10 is letter B. Okay. For letter C, same process, just different numbers now. Right? So we want to take, and I'll use the last ones again, from 3 to 9 is +6, from 6 to 10 is +4. So my ratio is going to be +4 over +6. That is a fraction, so you do have to leave it a fraction and reduce it. Do not ever give a decimal for these problems. Right? And 4 over 6 reduces to 2/3, which means over here on the left, that number 7 is letter C. And yes, number 9 is going to be letter D, but let's show you the process behind it and the ratio behind it, because you don't always get choices when it comes to these. So to get from 4 to 6, you're going to add 2. To get from 4 to 5, you're going to add 1. If you put your y over your x, it's +1 over +2, which does make 1/2. And if you look at number 9, it does have 1/2 in front of the x. That is the fastest way through those problems. Yes, there are other ways, and yes, you can get them right knowing other ways, right? But if you're trying to use what we learned in class, this is the best technique and the fastest technique. All right, for number 11, it is a multiple choice problem. Which of the following relations is not a function? When you have ordered pairs, not a function means that somewhere the x repeats. So if you look at letter A, 2, 3, 4, nothing repeated. If you look at letter B, 0, 2, 2, those 2's are in the x spot and they repeated. Letter B is not a function. Everything else has different x values. The y values do not matter, so don't even look at them. All right, for number 12, independent dependent variable. You are taking a taxi and being charged a cost for the number of miles you are being driven. Identify each. Right? So remember that the dependent variable has to depend on whatever the independent variable is. And if you think about it in terms of a graph, the x-axis would be your independent variable and the dependent variable would be your y-axis. Right? So in this case, the independent variable, the thing that's changing, is the number of miles that you are being driven. And because the number of miles are changing, that is going to affect the cost of the trip, or the cost of the taxi ride. So that taxi ride cost depends on the number of miles that you're driving. The more miles you go, the more expensive it's going to be, etc. All right, for 13, 14, and 15, you are going to either set up a table or set up an equation and solve for whatever it's asking for. All right, so sometimes this can be a little trickier depending on how your brain works and what mode you're trying to go through. For number 13, a table is the best way to get this, only because of the way it's set up and the pattern that you're going to discover. All right, so Joe was saving $1 the first week, $1.50 the second week, $2.25 the third week, and so on. How much did he save in week 8? And then what is the total that he saved for all 8 weeks? So we have 2 answers to give to this after we're finished. I'm going to make the table, okay, and it's going to have weeks as your x value, because time is always x, and then the money saved is going to be the y value. So in week 1, Joe saved $1. In week 2, he saved $1.50. In week 3, he saved $2.25. Right? Now we have to go all the way to week 8, so we might as well find the pattern and continue the table. And eventually we'll get to the answer for week 8. All right, now here's where you've got to use your y values to figure out what is the pattern that's happening. Right? And if you look at it, you can see the pattern and then continue it. From $1 to $1.50 is plus 50 cents. From $1.50 to $2.25 is plus 75 cents. Right? So we were going up by a quarter each time. So to go from week 3 to week 4, if he's increasing by a quarter, he's going to add $1. Okay? And then he's going to add $1.25. And then $1.50. And then $1.75. And then $2. So once you've discovered the pattern, you can use that to help you fill in the rest of the numbers that we don't know. All right, so for week 4, if I'm adding $1, I'm now going to be at $3.25. Right? For week 5, if I'm adding $1, I'm going to $1.25, I'm going to be at $4.50. For week 6, if I'm adding $1.50, I'm going to be at $6. For week 7, I'm adding $1.75, so I'm going to be at $7.75. And on week 8, when I add $2, I'm going to be at $9.75. Right? So for the first question that says, how much did he save in week 8? The answer for week 8 is $9.75. Now for the next question, it asked how much did he save in total for all 8 weeks. So you have to go back and add up all of the y values. So if you add all of them up, you should see that he saved a total of $36 over those 8 weeks by doing what he did. All right, so yes, a table is useful. If you can come up with an equation that works faster, you can handle it that way. Right? But I think most of you are going to see that the table effect for that one is probably the best way. Now for 14 and 15, an equation will work, and it will work very quickly and easily to your advantage. Right? So when we're looking at number 14, it says an electrician charges $45 for a service call and then charges $25 an hour. That means just to come out to your house, you have to pay the $45, whether they do anything or not. Right? But then every hour that they're there, they're going to tack on an additional $25. Determine how much the electrician charges for working in 6 hours. All right, so the equation is going to be Y, which stands for the cost, equals 45 you have to pay plus 25 times x. The x is representing the hours, right? And if you use the y and the x, you can see how a function comes out of this. If you use different letters, it'll still come out the same. Just make sure you're writing the equation and then using it to solve it. So because we are trying to figure out how much it costs for 6 hours of work, my 6 is my time, that's my x. So you're going to take 45 plus 25 times 6 to get the answer. Well, 25 times 6 is $150 plus that $45 just for coming out to the house, right? So for 6 hours of work for that electrician, he's going to get paid $195. Hopefully he fixes what he needed to come for. All right, number 15, similar problem, similar setup, right? Just a different scenario. All right, so you want to buy one CD case that costs $15 and several CDs that are $12 each. We're going to write a function and determine the total cost of your purchase, or that includes the total purchase before taxes. How much will it cost if you buy 11 CDs? All right, so the first thing we want to do is write the equation. Y is going to be the cost again. You have to pay $15 for the case because you're definitely buying the case. And then added to that, you're going to tack on $12 for every CD you buy. Well, you don't know how many CDs you buy unless they tell you, all right? But that's where the x goes. So this is the equation, the function equation, right, that you had to write, and now you're going to use it to come up with the answer. So y equals 15 plus 12 times 11. Okay, if you add your 132 to the 15, then you're going to get y equals $147, right? And that would be the total cost for 11 CDs. Okay, so when you buy the CD case and 11 CDs, $147 is going to be your total cost. All right, now for the back side of the review sheet, you're going to see a lot of domain and range things. Remember, we do different things for different ones depending on what the graph looks like. Right, so in numbers 16, 17, 18, 19, and 20, you have 3 things to do. You have to state the domain and range, and you have to answer the question of is it a function or not. So I want to go through and do all of the is it a function questions first. Then we'll come back and talk about domain and range for each one. All right, so for number 16, right, it's an absolute value function. It makes the v. So is it a function? Yes. It passes the vertical line test. Number 17, you have 4 random dots. No dot appears twice in a vertical line, so that passes the vertical line test. So that's a yes. Number 18, if you draw your vertical lines, it will hit only one time each way. So yes, that one is a function. Right? For number 19, you can't use the vertical line test because you have a table. So you have to look at your x values. Do any of the x values repeat? Yes, they do. So this is not a function. So that'd be a no. And then if you look at the mapping at number 20, first of all, the mapping is not done correctly. It does need labels at the top. And the person who created this, which wasn't me, included 2 2s in the left-hand side, which doesn't really matter in the grand scheme of things because the answers are still going to come out the same, but it's not properly drawn. All right, so having said that information and looking at the in column, does anything repeat? Yes, it does. So that would make this one not a function. All right, so now we want to go back up and look at domain and range. Remember, domain is the x values of the graph. So with number 16, because it is a continuous connected picture, right, you can't just list separate numbers, right? You have to actually use the inequalities that we were talking about in the such that statements. So for domain, we're looking at the x values, and because it's got arrows, that tells me it keeps going forever and ever in each direction. So every x value has a possibility in this one, which means the domain is all real numbers. Remember, with arrows, something has got to be all real numbers, right? For the range, it does not go forever and ever in both directions. It stops very clearly right here at the 3. So that is the lowest number it goes to. So we have a limitation on this. So we write y such that, and it's got to be all the numbers bigger than 3. So y is greater or equal to 3. And that's what your domain and range look like for number 16. Now, number 17 is not connected. It's just 4 random dots. So you can list separate values. You just don't want to repeat anything. And as you write them with braces, right? So please put your braces on the test as well. So for a domain, we're looking at all the X values. So if you take each dot and you come up to the X axis or down to the X axis and count where those lines are, right, you'll get all your values. So this first one on the left is at -1. Then we come across and we see one at +1, +2, and +4. So that's all your domains. Now taking those same 4 dots, you can do the same thing and go across to the range, which is the y-axis. And again, we're just listing them because they are not connected. So these two both have the same range value. So you're only going to write that number 1 time. So we're going to write a 2. Then this upper dot goes up here. Sorry, that's a -2. Then when that upper dot goes across to +1, and then the highest dot goes across to +3. Right, so do not list values more than 1 time when you're listing separate domains and ranges. Okay, so they don't repeat. All right, looking at number 18, this is a continuous connected function. So we have to include the such that statements, and it does have an arrow, but it doesn't have an arrow in both directions. So all real numbers is not going to be used here. All right, we have limitations on both the X and the Y. Right, the farthest point that it goes is right here. Right, it does not go anywhere beyond that. So for the X value, it's X such that. Right? The values of X start at 0 and go forever to the right. So that would be all values of X greater or equal to 0. Okay? For the range, right, that dot is the lowest Y value that it goes to. So it's Y such that Y is going to be bigger or equal to all things bigger than -2. Right? So that would be your domain and range for that one. Right, for number 19, you're back to a table, which means you can just list separate values. Do use those braces, but don't do any repeating. So for the domains, it's 3, 12, and 11. Do not write that other 12 because you already have 12 in your list. For the range, all 4 of them are different, so you have to list all 4 of them. -4, 6, 2, and 1. And don't forget your braces. All right, for number 20, for the incorrect mapping picture, but it still can give us the information we want. You do not have a continuous picture, you have a list of numbers. So domain would be all your X values, but don't repeat those 2's. So it's really just the number 4, -7, and +2. Okay, and then for the range, all of those numbers on the right-hand side are different. Yes, they have multiple arrows going to them, but that doesn't matter. So include all of the numbers that you see there, 9, 7, 0, 1, and 3. Okay, so that's the domain and range review to help you out there. All right, for number 21, we're going to talk a little bit about inverse. Right, from a table, this is your original table. Remember that the key word for inverse is switch. If you can remember that, you can pretty much do anything with inverses that you need to. So we are going to switch the values of X and Y. So this is going to be my inverse table, and literally from the original 1, 2, 3, 4, 5 is going to go in the bottom, 1, 2, 3, 4, 5 for the Y values. And then the Y values in the original, -4, +1, 6, 11, and 16, are going to become your new X values because they switched places. And that's done. There's nothing else to do to that. So take advantage of those easy ones that you don't have to do too much with. 22 through 24, you are going to evaluate given the value in parentheses. All right, so this is where you have to show your work, and you're going to use order of operations to help you do this. The value in the parentheses is your X. So everywhere you see an X, you take that X out and put that number in, and then you do order of operations. So we're going to find f of 2 by doing -3 times 2 minus 7. You must follow order of operations when you're doing this. -3 times 2 is -6, bring down -7. So the value for f of 2 is -13, because -6 minus 7 is -13. For number 23, be careful on this one, right? Because when we take and do f of -4, there is a negative sign in front of the x, but the value of x is also negative. So you have created 2 negatives in that problem. If you drop one of them, your answer will come out wrong, right? So now we know that -4 turns into a positive. So this is +4 plus 4, and that means f of -4 is going to equal 8. Right, for number 24, again, be careful. You're sticking a negative number in for a variable, which means you should be using and typing in your calculator parentheses. If you don't, it's going to mess you up. So -2 in parentheses squared minus 5 times -2 plus 8. Right, go through and do your order of operations. Exponents go first. -2 squared is +4. Then comes the multiplication. -5 times -2 is a +10. Then bring down the 8. Right, and because you've got all positive numbers, just add them from left to right. So f of -2 is going to equal 22. Right, so you will have a section that involves that, and you have to know where to stick those numbers and letters in the right spot so that you can do the right kind of math. All right, for 25, there's a variety of answers to this one. All right, so if you don't get the exact same answers that I do or you need some more explanation, don't hesitate to ask about this one in class. It asks you to give an example of a set of ordered pairs that has 5 elements in its domain. That means 5 separate numbers in the domain and then 4 elements in the range. Right? So in order for that to happen, the 5 elements in the domain have got to be different. So you're going to write 5 ordered pairs, okay, with your braces in the front and the back. And all 5 values for the x values are going to be different. So you can pick any numbers you want to as long as they're different. So I'm going to go with 1, 2, 3, 4, and 5. All of them are different, and it's in the domain. Now for the range, you only have 4 different elements, which means somebody has to repeat. So whoever you want to repeat, just make one of the y values repeat. You have to have 4 different numbers, though, for your range. So I'm going to do 0, 0, 1, 2, 3. You'll notice that my zeros are the ones I chose to repeat. So I only have 4 range values right now and 5 domain values. Now, that's my example. So then the question is asking you, is that a function? Well, because all the domains were different, you say yes. None of the x's repeated. Now, if you take and do the inverse, which means you flip the x and y values around, is the inverse a function is going to be no, because of these 2 ordered pairs right here. As soon as you flip them around, you've got 0, 1 and 0, 2, and now you've got a repeating x value. Okay, so that's just trying to get you to understand the whole inverse bit again. All right, for number 26, this is where we use colored pencils in class, right? And this is where you may want to use colored pencils on the test, and I will have those available to you when you take the test. Right? There's a lot of things going on with this. It's like 3 separate problems built into one. Right? The first thing we want to do is graph the inverse of y equals 3x plus 1. Well, you can't graph the inverse until you graph the original. We can't graph the original until we have the y equals x line. So the very first thing you want to do anytime you see a graph related to this type of problem is draw that y equals x line right there in the middle of your paper and label it so you know that that's what it is. And it should be dashed. Don't ever make it solid. All right, then you're going to have to come up with a table to make the original equation because you can't just graph it if you don't know what values to use. So for the original, we're going to create our table with 3 values. The easiest ones to use for our equation is -1, 0, and +1. And that's going to allow us to graph it. So when we plug -1 in, 3 times -1 is -3. -3 plus 1 is -2. Plug in 0. 3 times 0 is 0. 0 plus 1 is 1. Plug in 1. 3 times 1 is 3. 3 plus 1 is 4. You've now created the 3 ordered pairs that will make your original line. So now graph them. And if you're using color pencils, this will be one of your colors. And then the other one will go for your inverse. So -1, -2. 0, +1, and +1, 4. Let's be right here. Take your straight edge and connect it solidly. Put your arrows at the end and label that your original. Right, now, to do the inverse, which is the whole point of this, is showing what the inverse is going to look like, you have to take and come up with your inverse table before you can make the picture happen. Right? Remember that the inverse table is very quick and easy to do after you have the original. So you're going to take your original table and you're just going to switch the values. So my x values are going to be -2, 1, and 4. You've already done the math and the hard part. So now it's just switching them. Your x is going to be -1, or sorry, your y is going to be -1, 0, and 1. So now you're going to plot those 3 points on your graph. -2, -1, 1, 0, and 4, 1. Which should be right here. And then take your straight edge once again, connect them, put your arrows on the end, and label it inverse. Right? Now, if you've done this right, remember, if you were to fold this graph across that dashed line, you would have a reflection across that line. So, and I can tell by looking at it that this is going to do the same thing. All right, so that part is done. The graph part is done. So now the next piece is the inverse a function? So is that line you just drew with the inverse values, is it a function? And the answer to that would be yes. It passes that vertical line test. So we're good on that one. Now, for the equation purposes, we want to write the equation that is representing that inverse line. So here's where we go back to the original equation of y equals 3x plus 1. Remember, inverse is all about switching, so we're going to switch the letters. It's going to say x equals 3y plus 1. And remember, we always have to solve it for y. So we've got to do a little bit of math here. We're going to subtract 1 from both sides. Now we've got x minus 1 equals 3y. We have to get rid of the 3 by dividing everybody by 3. and then we need to clean it up a little bit. Now, when you write your final equation, remember you have to write the inverse symbol for notation. So it's going to say y with -1 in the air. That's the inverse of y is what you're telling me. Equals x over 3 is really 1/3 x, and then minus 1/3. So this equation right here is the inverse of the original one you started with over here. Okay, and typically remember that your inverse most likely will have fractions in it if your original did not. Not always, but most likely. Okay, so you can kind of use that as a gauge. All right, but all of these topics will be on your test. So this is what you want to study and prepare for and make sure you understand.